Good morning to all. Myself Sunil CK. I'm presenting a paper called Comparative Analysis of Intrusion Detection System using Machine Learning and Deep Learning Techniques. It is co-authored by Sujan, Sandeep, Shashikanta, and Nagama Patil. Our presentation goes like this. Introduction. Intrusion Detection System. It's a system that protects the network from suspicious and harmful activities. It scans the network for harmful activity and any potential breaching. Intruders use weaknesses in the network, such as poor internet protocols, bugs in source code, or some network flaws to breach the security. Intruders may try to access more content than what is possible with their current rates. And the intruders who try to steal sensitive and private data from the user's system. There are two types of intrusion detection systems, such as signature-based and anomaly-based intrusion detection system. Signature-based identification relies on examining network packet flows and compares them with configured signatures of previous attacks. And the anomaly detection techniques works by comparing given user parameters with behavior that deviates from a normal user. In this paper, we are trying to improve the performance of the intrusion detection system by applying different machine learning techniques and finding the best features by applying a different machine learning techniques and classifying the things by using the different machine learning techniques and compare our results with the different machine learning models and compare the results with the k-based features with respect to accuracy for a specific features, k-based features we have checked. So the literature survey, we have used some of the papers. The first paper, they have discussed the feature selection using various machine learning algorithms to perform the comparative analysis. They have used the hybrid intrusion detection systems, which are created by stacking multiple classifiers together. In the next paper, they have discussed the different ways of combining feature selection and machine learning techniques to perform comparative analysis most effectively. In the third paper, they have considered the real-time intrusion detection system, and they have used a dynamic changing model. Once the data is gathered, it uses the XGBoost techniques to ensure maximum results are obtained or not. And the authors used in the next paper, they have used the machine learning models in real life activity. Okay, the authors use genetic algorithms and decision trees, which are then used to automatically generate rules which are used to classify the network connections. The next paper, they have used the pigeonhole inspired optimizer for the feature selection and decision trees for the classification purpose. In the last paper, they have used autoencoders for getting the compressed feature representation for the dataset, and then they have trained the model on a different machine learning model for the prediction purposes. In most of the cases, in the literature, they have observed that feature selection techniques are not well utilized, or a simple statistic-based approach has been used to select the features, which is not a robust method for feature selection. Results are not compared with the ensemble techniques. To overcome all these things, we are using ensemble model in our work. And the problem statement is comparative analysis of the intrusion detection system using machine learning and deep learning techniques. In the proposed approach, we have used a dataset called NSLKDD. It consists of around 130,000 traffic records, and it has many. The dataset had many classes, and so that we have combined some of the classes into one single superclass by one superclass to the main reason for that is we merge the similar, means we have merged the similar intrusion attacks into single attack to reduce the number of classes. One reason is to merge classes is the high class imbalance. That is, some of the classes is having lesser instances that may not be that may not be good for the classification purposes or identification purposes. So this can lead to the problems while training the data set. So that is the reason we have merged some of the classes into the make it to the single class, and in the combined in the updated data set we have it has 4 attack type classes and 1 normal type class. So these are the data set we have and total of we have for the training purpose we have used 1,25,973, and for the testing purpose we have used 22,544, and we have applied the data pre-processing techniques called min-max scaler. Here x scaled means the scaled value of x after applying the scaling methods, and min means the minimum among the column, and max means maximum in the given column, and the x is the given input. Best feature selection. We have used a scale select k based information gain, random forest feature selection, and Pearson coefficient for the best feature selection purposes. These are the different machine learning models we have used to select the best features among the dataset. And we have applied stacking ensemble model for the baseline models that autoencoder, neural network, and random forest are used as a baseline model, and then we get into the XGBoost model to get a result. In the neural network model, we have used a deep learning model which has 4 layers. In the first layer we have used the 16 nodes, and the second and third layer we used 8 nodes each, and the last layer will be 1 for the classification purpose, and we use the rectified linear unit as an activation functions in this in the neural network model. And the random forest is it has multiple decision trees in it's a kind of forest. This will ensure that no particular decision tree will be overfitting, since no tree considers all the features. Okay, we'll take the average of all the average of the importance of the nodes in each tree. And the autoencoder will be having 2 components called encoder and decoder. This autoencoder is trained in an unsupervised fashion to learn a compressed version of the input, and then these things will be fed to the XGBoost model. And XGBoost is used to combine the predictions of all base layer models. This is responsible for obtaining a nonlinear combination of individual base layer models. And the experimental analysis. So here we have selected the different k-based features, such as means different number of features called 15, 20, 25, 30, and 35. We have compared the results among them. We have used random forest as a feature selection model, and Pearson coefficient, and information gain, and select k-based features. So these are the different models to select the best features. Out of that, select k-based feature selection model has performed well with the 99.93% with the 15 number of features. It says that by using the more number of features are irrelevant. Only 15 number of features can give the good result as compared to the other one. And we have used different machine learning models to classification purpose called random forest, neural network, autoencoder, and XGBoost. And XGBoost has performed well with 88.81% as compared to the other models. And we have used different performance metrics such as accuracy, recall, precision, and F1 score. In all the cases, XGBoost performed well. And we have compared our results with the state-of-the-art architectures and ensemble model. So in this, we can observe that ensemble with the XGBoost model is performing better as compared to the other models, other state-of-the-art models. And conclusions, we have this is a comparative analysis was made on different sets of features. It's different k set of features we have taken, and it is observed that feature selection algorithms have a significant effect on result of the model. And we have seen that only 15 features are able to give a good result as with the whole data set as compared to it is not compared to the more number of features. Means once we get the k-based features, and the remaining features are not contributing to the classification purpose. So we are concluding that the k-based features we selecting from the different machine learning models are enough to make the classification. So this will make the this will reduces the computation complexity as well as the training time of the system. And the model is trained with random forest classifier, and as we discussed, neural network, autoencoder, and XGBoost. The ensemble model performs best as compared to the other models. And these are the these are the references we have used. And thank you.